Today we're going to be deriving the product rule for calculus, and we use the product rule for calculus every time we're trying to find a derivative of a function multiplied by another function. So if f of x here is a function and we're multiplying it by g of x, which is another function, if we want to find the derivative of that, we would have to use the product rule. I'd like to remind you here, the definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So using this definition here, we're going to start deriving the formula. So if we want to find a derivative of h of x, which is f of x times g of x, we can use the definition of a derivative here. So h prime of x is equal to the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x. All this over h. Now we're going to add a few terms to this. It might look a bit strange at first, but you're going to have to bear with me a bit here. So we're going to subtract it by f of x times g of x plus h all over h. Then we're going to add it by f of x times g of x plus h. All over h. Okay, so why are we allowed to do this? Well, the reason why we're allowed to do this is because all of this is equal to 0. This is the same as this, and what we're doing is we're subtracting it and then we're adding it. So it's very similar to doing minus 1 plus 1, which all of this just equals to 0. We're not changing the value of this expression in any way, so that's why we're allowed to add and subtract these two terms. But the reason why we actually have to do it in the first place is it allows us to simplify this entire expression into something a lot more nicer. So we're going to add and subtract them in a very specific order. We're going to put the first one here, and we're going to put the second one here. So let's write our new expression. H prime of is equal to the limit as h approaches 0 of f of x plus h times g of x plus h. We're going to use the first term here, minus f of x times g of x plus h plus f of x times g of x plus h minus f of x times g of x. And all this is over h. Alright, so this looks like a monstrosity of an equation, but believe me, this thing simplifies into something a lot nicer. But first, we're going to have to split this equation up by cutting it in half. So if we took a saw and just cut this equation in half and turn it into two limits, we're going to get h prime of x is equal to the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x plus h all this divided by h. And we're also going to add it with the limit as h approaches 0 of f of x times g of x plus h minus f of x times g of x. All this over h. Okay. So now we have to observe both of these separately, but there's a key observation you can make right here. You notice that both of these terms have a g of x plus h. So you can factor that out in front. Over here, both these terms have an f of x. So you can factor this out in front. Let's rewrite this in its factored form. H prime of x is equal, limit as h approaches 0, of g of x plus h times f of x plus h minus f of x all over h plus the limit as h approaches 0 of f of x times g of x plus h minus g of x all over h. Okay, now we can finally take the limit and watch what happens. So, when we take the limit on this expression, h goes to 0, so this h disappears. So we're just getting g of x. Over here, it looks a bit fancy, but what this really is just a definition of the derivative. So, because it's f of x plus h minus f of x all over h, this just becomes f prime of x. Here, there's no h term, so we don't need to worry about this f of x. But over here, it looks fancy again, but it's just the definition of a derivative, but instead of f of x, it's g of x. So this becomes g prime of x. So after taking the limit, what we end up getting is h prime of x is equal to g of x times f prime of x plus f of x times g prime of x. And that is the product